So let's try this. What about this? What are we gonna do? Which ones you want to go through on this? Okay, you had 5, question 5.
What is that? Use it to go focus.
2.4, practice 3.
Whew.
Okay, let's step through this one. I think so. Okay, so what about this? What are we gonna do if we're differentiating? So let's write the function down first, and we'll just erase it piece by piece. But we got to do it. We'll each layer at a time, right? So what's the outside layer here?
2.
Meaning squared. Okay, so I've got hand squared. So y prime equals, first layer is going to be 2 times hand to the what? To the 1. Okay, so that's t squared on the top, t cubed minus 5t, and we can erase the outside layer. So the next link in the chain is a quotient rule. Yeah, right? So we're going to multiply this by quotient rule. So what's the quotient rule going to give us? Low d high, right? So t cubed minus 5t times 2t, derivative of the top, 2t minus pi d low. What's d low? Minus, okay? All divided by right? So that's, and then we're done. That's our derivative. So all we have to do is just clean that up a little bit, right? So what could we do? There is, in the top, I've got these two terms. I could factor out a t, it looks like, right? That might help a little bit. So if I just write this as a bunch of stuff on the top and a bunch of stuff on the bottom, I've got my 2.
You could factor out t squared, couldn't you?
I could. I could take a t out of this guy too, couldn't I? Right?
Yeah.
So I could end up with 2t squared, and if I undistribute a t squared there, I'll just write it separate so we can see where it came from. And then on the top, what am I left with? I'm left with, if I take a t squared out of that term, what's left behind? That t goes away, and I take 1 from there, right? You don't have to do it this way, but it's a good way. So I'd be left with t squared minus 5 times 2 minus, and I can take, I took a t squared out of this guy too, right? So he's gone. Minus 3t squared minus 5. That's everything on the top, right? If I factor a t squared out of this guy and a t squared out of this guy. Right? What about the bottom? We'll come back to the top. But while we're at it, on the bottom, I've got a t cubed minus 5t times a t cubed minus 5t squared. So what's on the bottom? Yeah, t cubed minus, I don't know why that's green, minus 5t cubed. Okay. And then now all I have to do is just combine those into a t to the fourth and just distribute and add like terms there, right? Did I have to factor all that stuff out? No, I really didn't. I could have just distributed the 2t and distributed the t squared, simplified all this stuff, and then factored out a t squared afterwards too. Would have been fine. Okay. Sure. Well, should we finish this? So I get 2t to the fourth, and then if I distribute the 2, if I distribute the 2 in the negative, what am I going to get? 2t squared minus 3t squared is negative t squared. Negative 10 minus negative 5 is minus 5.
Also, are these problems designed to get harder and harder the more you miss them?
No.
Okay.
Does it feel that way?
Yes.
No, they're not. Okay, so that's my answer. Personally, I would put the negative out front too. You don't have to, but I would make that. I would make that a negative and make those positive. Okay. Okay. Make sense? But really, the calculus is done there. We did the calculus, now it's just some algebra. And this is class is mostly algebra. Okay, another one. Katie, you said number 2? Okay. So, something like this. Oops. 2. Just some more practice. So our function is a cosine of something, and that something is an exponential of something else, and that something else is like a polynomial or a power function. So if I want to do y prime, what's the first letter we see? Right? Cosine? So if I take the derivative of cosine, what do I get? Negative sine, good, of something, okay?
Which one is this?
This is number 2. Okay, so we can erase the first layer. Sure. So the cosine's gone, what's the next layer? Well, it's base e exponential, right? What's the derivative of e to something? Okay, so the next layer is just times, so the next link in the chain would just be e to the minus 2 theta squared, right? And then if we look inside that layer,
Me too. I entered a 0 in one of mine.
oh, because the theta looks like it. Yeah, I got you. So now we get a 2, and well, 20 squared would be kind of weird. You know, I mean, you'll probably get a sense pretty soon that that's, probably look for that being a variable. So then the derivative of negative 2 theta squared is what? Negative 4 theta, that's it. So there's the calculus. I could just pull that out front, pull everything out in front of the trig function. And the negative times negative is positive. I'd get a 4 theta e to the negative 2 theta squared times the sine. Just if you want to write it in that best way.
So,
You don't have to do it that way to get it right, but just get in that habit. Okay?
well, where does the negative?
With that negative right there, that
So
multiplying
that's all
together.
you can simplify it?
Yeah.
The y?
Yeah, I don't see what else you can do. Well, inside there, of course, you got your e. Okay? What else? 6?
Yeah.
I'm doing it wrong. This is like. Oh, I got it right.
So on this one, if I were to write the radicals as fractional exponents, that's just gonna be a 1/2 power, and inside I've got an x to the 1/2, right? So first thing I'm doing, the outside layer would just be a 1/2 power, right? So first layer is gonna be 1/2 times something to the negative 1/2, good? And so that's going to erase all that stuff, right? So the next link, is the derivative of that layer. What's that look like? Derivative of that layer. We undid the outside layer. Good. That's my answer. I just have to clean it up. Yep. Oh, okay. So if I clean all that up, let's just write it top and bottom. So on the bottom, I've got a 2. On the top, or on the bottom, I've also got a square root, it looks like, of all that stuff. And then what have I got here? I'm multiplying this whole thing by by 10 plus 1/2. So all that stuff really could be on the top, right? In fact, let's do that. Let's just move it over to the top. And so technically, I wouldn't really want to leave it that way. I'd want to get a common denominator up here, but, I mean, that's the answer, right? Okay. Do they let you put, they probably let you put it in like that, don't they?
Yeah.
Yeah.
Could we go over the number? And
Sure.
could I give you the values?
Sure.
Okay.
Are you, everybody done with this one?
Wait, oh, wait, let me just.
Can you like 10
Last
minutes?
one, they're still wrong.
What?
Really?
I don't know why.
There's one that I, oh,
Really?
I did
Yeah.
mine and that
I
one,
got
that one I just.
27.
That one's right.
The rest of it,
This
it's
one's
saying
wrong.
it's 2.
Okay, but this way, which one are you doing?
should be,
Should be eight. Yeah.
Yeah, that is right. Yeah. Okay, Elton.
okay,
Go.
X times.
This is like y equals this?
What, yeah, y equals X times the quantity, 3X minus 9.
Cubed?
Yeah.
And we're just taking the derivative of that?
Yes.
Okay. All right. So y prime, we gotta use the product rule, right?
Yeah.
So we're gonna get x times the quantity 3x minus
Factor a
9.
9 out of the beginning already.
What's that?
You can factor a 9 out of that right there.
A 9 out, what do you mean?
You can wait, no,
I don't wanna do, I mean, I gotta be careful, because it's being cubed.
D cubed, so you have to factor out.
I'd be factoring out a 27, but I don't really wanna do that, though. I mean, I think if you try to do that, you're gonna make mistakes. I wouldn't do that. Technically, you can, but you gotta be real careful, right?
Wait, why is it squared?
Well, because I'm taking a derivative. I haven't put the 3 there yet. So times the derivative of all this stuff. Because here's my u, right, and all this stuff is my v. So I'm going to multiply by 3 times the quantity 3x minus 9 squared times what? By the chain rule, if I'm taking the derivative of hand cubed, I've got 3 hand squared times the derivative of what's inside, which is a 3. Plus v times du, which is just 1, right? Okay, so all we got to do now is just factor out our like base. If I were to clean this up, does everybody agree this first term would just be a 9x squared times 3x minus 9 squared plus 3x minus 9 cubed. So I could factor out, I've got like bases here of 3x minus 9, so I could factor out a 3x minus 9 squared, right? Everybody good with that?
Why is it x squared?
Did I do something wrong?
X
Where
did the squared part of it?
Oh, right here you mean?
Yeah.
I just cleaned this whole first term up, so everything in here is there.
What's the X squared?
9x. Because you got 3 times 3 times x.
Oh, you're right, there's no x, which is 9x, you're right. You're right, my mistake. There you go, it's better, okay? So if we can factor out our like base of 3x minus 9 squared, leaving me with, that whole thing's going to cancel, so I'm going to get a 9x plus, and have one more of those bases left over. And that's going to be my final answer when I just combine that stuff. Let's go down. So I'm going to get a 9x plus 3x is 12x minus 9. I could factor out a 3 if I wanted.
And you can factor out a 9 of the first one, leaving you with x minus 3. So
I could.
3 times 9, you get 27. Mine's saying the answer is 2 times.
Oh, that.
Yeah,
Yeah.
Is this one just wrong on here? No.
Well, what's it say the answer is on there?
It keeps
2
giving you.
times the quantity x minus 3 squared times the quantity 4x minus 3. I got that it should be 27 times the rest of it, step 2.
Yeah, because I had this different problem, that was the exact same answer. That was the exact same problem.
Be amazing, put in the 3x minus 9 squared times 12x minus 9.
You did.
Yeah.
So did I.
Oh, so maybe that one is wrong.
Okay.
What number is that one? Is this one the same every time?
8.
I have the same.
I have the exact
the-
Okay, so that one's wrong, so I'll fix it. Which number, that's number 8?
So we want both values 3.
Okay, I'm just gonna make that one worth 0 for now on the assignment, so it won't impact your
You
score.
just change the answer to out of sevens and answer fixes it.
Oops.
Yeah, that one there was really confusing.
Okay, I'll fix that one.
Yeah, because the answer that you do with these items, it's not going up. The bottom one is going up.
Oh, what the heck?
That's stupid, stupid. Lower that up and take over the world, that's it.
The only way they'll take over the world is after I invent consciousness. That way we'll no longer be stupid.
Implying you're stupid now. No.
And he's saying, oh, but his consciousness is stupid on this.
Okay, anything else?
So
On there.
what did you do to that post?
I think I'm just gonna have to give everybody, like, I'll just add a certain amount to every assignment on it. Everybody's assignment. I think I can do that. I mean, worst case scenario, I'll just give everybody 100 on that assignment. I don't, it's, as long as you're, just do it for practice, but I don't care about the points. I'll give you credit for the whole thing. Any other questions on that one, though?
Can we just have like a work day and then as we get questions, can we ask them?
Do you guys, do you feel like you, so tomorrow's gonna be, I'm gonna be gone, it's gonna be a work day. Do you, if you tell me that you, in all honesty, you think you really need a work day today to get some stuff answered, I'll give it to you, that's fine. You really, if you do,
Yeah,
okay. So you can work and I'll do this, how about?
yeah, if I work on myself, I still have my
Okay, all right, so what other ones?
We have number 9.
Okay, well, you got these ones, so these ones, why don't you, I'll do ones like them, but these ones, you don't get any different problems on them. I mean, if you want to talk about how to do them, that's fine. But I'll leave those for you. And you can even see the answers. On these, you can actually see the answer, and you get the same problem back. So if you want to get credit for it, just put the answer in. But you just got to know how to do it. Right? If you do it a certain number of times, doesn't it show you the answer?
Yeah,
And if you reload it, it gives you the same problem back, like on numbers 7 through 12.
It said like, not quite, and then when you finally get it, it's like, bingo, it's like, oh.
So what's this, real quick, what's that going to be? How are we going to do that one? Product rule. Right, it's a product rule, but when you differentiate, but V prime just requires chain rule, right? Because it's a 1/2 power. Okay? What's that one going to be? What rule am I using? Quotient rule. But once again, V prime is going to be, it requires a chain rule, right? Okay, what about, should we look at 2.4 practice 4?
Yeah.
See if you have any questions on that.
So for one like that,
Mhm.
you put in, you take g of x and put in the f of x before you take the derivative?
Yeah.
Or after?
I would do it before. You can do it either way, really. let's look at this. I kind of meant to take that one off, but it's all right. It's not a bad one to do. So if f of u is this quotient and u is equal to g of x, which is that polynomial, right? And they want you to calculate the derivative of this thing. And you're going to evaluate it at 0, but the big thing is we have to just calculate the derivative of this thing. Well, what's that function going to look like? What's f of g of x even going to look like? Right? Wherever g of x is, that's just we're going to substitute that for u, right? So we're just going to end up with 2x squared plus 3x plus 5 times 2 on the top, divided by that whole quantity squared plus 2, right? What would you probably, I know what I would do on this one, probably. I would for sure distribute the 2 on top. And I'm not even sure I wouldn't expand the bottom out too. It's be about this type. It's not going to be that much different. But I think expanding the bottom out, at least you won't have to do, I don't know. Either way is going to work. I mean, yeah, at least you're not going to have to do the chain rule on the bottom. There's not a clear cut. They both would work. You're either going to do some simplification before you do the derivative, or you're going to do a bunch afterwards. Right? Okay. But actually, let's be smart about this though, because think what they're asking us. They're asking us to evaluate this at 0, so there's a really important lesson here on this one. Do we need to do any simplification on this? No. How come? Because we're just going to plug in, we're going to evaluate the derivative anyway, and so it's going to self-simplify. You start plugging in 0 for x, everything's going to get real simple, right? So why waste all that time simplifying the algebraic expression when you're going to plug in zeros anyway, right? So all we'd have to do on this one is just follow the chain rule. It's going to look terrible, right, when you're done with the calculus. Let's go through this one. How about it? This is actually a pretty big point. If I do the calculus on this, there's my function. If I differentiate this, I got to use the quotient rule, right? So f prime is equal to the bottom times the derivative of the top, which is going to be what? 2 times 4x plus 3, if I just leave that 2 out front, minus the top times the derivative of the bottom. And I can't even write all this stuff down. So this is same line, times 2 times the quantity 2x squared plus 3x plus 5 to the 1 times the derivative of that. It looks terrible, but who cares? All that stuff divided by the bottom squared. That's horrible, right? But who cares? Because we're going to evaluate it at 0. So when I evaluate that big ugly derivative at 0, what's left behind? Almost nothing, right? Look what happens. Everything with an x in it is going to 0. So what am I left with? Well, I've got a 5 squared, so 25 plus 2 is 27 times 2, so I've got a 54 minus 2 times 5 times 2 times 5, so 100 times 3. Well, it's just messy up here, isn't it?
That's one word.
Yeah, so this, this is a one word. So this whole thing is 54. Let's do it this way. This whole thing right here, this whole term is, I can do that right, 25 plus 2 is 27 times 2, so that's 54. This right here is going to be 10 times 10 times 3, so minus 300 divided by, the bottom is going to be 25 plus 2 is 27 squared. Yikes, what's that? For somebody with a calculator, what's that give us? 54 minus 300 is 240, negative 246. What's 27 squared? 729. So that must be, if I divide those by 3, that must be 3 times that, right? So what happened to the top then? I think we must have made some little mistake there. Oh, the 2.
So multiply.
I forgot the 2. See where I forgot a 2? Right there. There's supposed to be a 2 there. So that should have been 108. Minus 300, so that's 2, that's gonna work. That's gonna work. 192, yeah, it's 192 on the top. So it simplifies. $192 divided by 3 is 46. If I just divide top and bottom by 3, and I can see they're both divisible by 3 because if I add the digits up, right, I get a number divisible by 3. So I know I can divide 3 into both those. That looks terrible because it's all written. You can't write it out on one line. But my point being that when you do all this calculus and you know, it looks like a lot, but if you just follow the quotient rule using the chain rule, even though the result looks terrible, when you're going to evaluate it at 0, all the x's are going to go to 0 anyway, right? So it makes it a lot simpler. Yep. Question?
Well, after this question, do you?
Sure.
Because it was the one that.
Which one are we doing?
It's 2 on mine. It's the one where it's cosine t and then x equals cosine t and y is
2.4, practice 4? Like, something like that? Okay. Okay, this one is not a big deal. This is like kind of the one we went through yesterday. This is using that trick. Okay, so let's review the trick for Kirk. Kirk needs some help with the trick here. So we have x of t, right? We know that x of t equals negative cosine t. Y as a function of t is 7 plus sine t. And if we want to find the equation of the tangent to the curve, we're really just finding y prime, right, to find the slope. We need a slope of the line and we need a point. When t equals pi halves, x is just equal to, well, we're just going to evaluate x at pi halves. What's x of pi halves? What's that going to give us? Pi halves, that's going to be 0, right? Y at pi halves is 7 plus negative 1, so 6. So the point of tangency is just going to be 0, 6. Right? Now we need to know the slope of the tangent line, though. The slope of the tangent line is just gonna equal y prime at t equals pi halves, because that's the value they're giving us, right?
Why is it negative one?
Oh, you're right. It's positive one, so it should be 8. Yeah, you're right. Good job.
Wow.
All right, so I'll make that red. Highlight the difference there. So that's supposed to be an 8. There you go. Okay. There we go. Good, good. Okay, so then we just need to know, to find the slope of the tangent line, we've got to find y prime, right? So y prime is just dy dx. I've got y as a function of t and x as a function of t. So that's where I could say dy dx is the same thing as saying dy dt divided by dx dt, which is equivalent to dy dt times dt dx, whichever way you want to think about it, right? I think this is a little bit easier to think about, though, because I've got these functions written already in terms of t. So dy dt is just going to be, what, cosine t? Dx dt is going to be positive sine t. So my derivative function is just going to equal cosine t divided by sine t, which I could write as cotangent if I want to. But we're just going to evaluate it at pi halves anyway, right? So the slope of the tangent line is going to be cosine of pi halves over sine pi halves, which is 0, right? In this case. So I've got a slope of 0, point of tangency of 0, 8, and so you can see that what's the equation going to be? If the slope is 0 and it's going through the point 0, 8, it's just going to be y equals 8, right? But even if we went through the whole process of putting it into point slope form, I'd get y minus 8 equals 0 times x minus 0. Well, what do I get? Y equals 8. Okay? Make sense? If you missed yesterday, that would have been probably a little tough to do. Yeah. All right? How about something like that? Same kind of thing, right? I would just calculate, I got to calculate y prime, which is going to be dy dt over dx dt, and then find my point of tangency by evaluating both of those at 1/16. Okay? Get something different. This is slightly different, this next one. Okay. That looks more normal, right? I'm just going to take the derivative, evaluate it at 9 to find the slope. Evaluate the function at 9 to find y. I got a point in the slope. All right, that's fair. So you guys have got tomorrow to kind of catch your breath too, and we'll see you kind of touch base on Monday. Monday, let's plan on hitting the log stuff a little bit more. Okay?
Just that,
It's both. PR5 is just, let me double check, gotta make sure. I'll change all the dates on those then. I think PR5 is the one where it's just pre-calculus review of logs.
over logs. That's a big.
We'll go through it more.
Monday.
Monday. So Monday we'll just continue talking. So 5 is no calculus at all. That's the stuff we'll continue talking about Monday. That's just pre-calc review of logs. 6 I'll push off for like a week or so, and that's gonna be the one where we're gonna actually start doing derivatives of logs.
So we're gonna talk about logs tomorrow.
I'm at a basketball game tomorrow, but Monday we'll talk about logs.
So yeah, what page?